In the next video segment, I'll use the handler thread to recode the example where I add two numbers in the background. But before I jump into coding using the handler thread, I would like to go over the handler thread concepts. So that's the topic of this video segment. So it's important to understand the underlying concepts before going further if you're new to multi-threading. Okay. So the basic idea, the basic question is like, how do we actually write a long-term thread, or how do we actually communicate between two threads? Previously, with the async task, it's kind of like magic. Like in the background thread, you call this function, okay, publish progress, and then this function triggers the on progress update function on the GUI thread. It just happens magically. The framework does it for you. The async task class is doing it for you. So how do you do it yourself? So that's the key. How do you do these communications yourself? Okay. So I have like, well, my activity is just bare bone again because I'm starting all over again, right? But I'll code in some pseudocode on how do you actually write the background thread, the so-called long-term thread. Okay, so this is just mostly pseudocode. I'm leaving out a lot of details. So it's my thread. So what do people want to do with this this background thread of yours? Is they want to start, okay, and they want to quit, basically, and they want to do something. Let's just call it like do xxx. It doesn't matter what it is. It's just conceptual. So this thing needs a runnable, right? So let me have a runnable, my runnable. So the runnable has a run function. So let me have a thread called background thread. Okay. So the start function would start this thread if it's not running, right? If the background thread is not running, the start function starts it. So that there's not much there. You just create a runnable object and then call start. But of course you have to detect that it's not currently running. If it's currently running, you ignore it. Okay, it's already running. So quit is just the interrupt thing, like that. That's just how you quit. Oh, usually you do want to wait for it to actually finish. So usually something like that. Let's run a try switch. Okay. So this one is where the key is at. Okay. Now it's and also this is the actual thread. See, the start, quit, and do xxx. That's the front end. These are all on GUI thread. So let me just comment that in as well. Running on GUI thread, right? This is on GUI thread. This is the one that's on the background thread. Okay, so this is on background thread. So how do I? This is on GUI thread. So how do I communicate stuff over here? Okay, so that's one question. And also, well, first of all, it's a long-term thread, so that means it never really ends. Okay, how you communicate is by passing messages. Okay, so the thread itself never really ends. Process message, after it's done processing messages, go to sleep, right? And when it sleeps, this thread is gonna be blocked. So it exits the while loop by that interrupt mechanism. Interrupt or something. Yeah, so when the GUI calls the quit function and quit function calls interrupt, that's gonna cause an interrupt exception to be thrown. So this is your quit code here versus your real error handler is gonna be here. So your error handling code here versus the code that handles quitting. In either case, there's a cleanup block. The cleanup code is gonna go here. Okay. So a couple more things. Talk about this message passing thing. So running on GUI thread. Okay. Send message to background thread, right? And then in the background thread you process a message. Let me take care of this. Okay, so you need a message class, some kind of message class. So message class usually like there's a message ID and there's a payload. Okay, and what the payload is depends on the message ID. So that's just general idea. And yeah, I prefer to have a shared class to explicitly state what's shared. So there's gonna be a wait flag such that in the run function, in the runnable class run function, it's an infinite loop. So you process your message, you're gonna go to sleep. So it's gonna be this is done by using the wait flag. Well, of course, then you need the share object. Okay. So it's like the share dot wait flag. Wait. Okay. So the background thread that's processing the message is gonna process message, go sleep. Now in the GUI thread, the foreground thread, after you send a message to the background thread, you need to wake up the background thread because it is sleeping, right? So it's like this. Yeah, so just call notify. That's how you do it. So now I want to go over this part where you send a message to a background thread. So the way you do this is have some kind of message queue. So both the GUI thread and the background thread will share some kind of message queue. Okay, bring that in. Just a little detour about the queue. There's actually no queue in Java. the queue is an interface. Okay, so it's gonna be like a linked list or something. But just be careful because in some languages there's actually a queue, right? Because in C#, for example, there really is a queue. Right, a queue. A queue is really a class that you can instantiate, whereas this one is an interface. So in this situation, in this particular language, don't do this, right? The queue, no such thing, right? Use a linked list or something. Okay. But in other languages, you can actually instantiate queue. So just a minor detour about that point. Okay, so you have a message queue that is shared between your foreground thread and your background thread. Now, in the foreground thread, you just create a message. Where's that do XX thing? Oh. So you create a message, new message, right? You do the ID, like 23, whatever it is your message ID, and your payload might be null, whatever. Okay, you set your ID, you set a payload. Now you put that inside your message queue. Now this is the key part. Here you synchronized share message queue because this is a share object. So message queue that I think it's called add, right? So message here. So like that. Okay. So on the foreground thread, you send a message to the background thread by creating a message object and stuffing in this queue. And then you wake up the background thread, okay, using notify. And the background thread, you process the message. So you unload the synchronized shared if empty or something is empty. And so there's stuff in it. Remove, right? Read from the message queue using remove. Okay, so and then you process the message. So when you process the message, is you look at the ID. Well, first of all, if this is equal null, right? Right, because if the queue is empty for some reason, well, okay, explicitly, okay, the message will be null. If the queue is empty, the message will be null. So, okay. So if the message is not null, then you have this big switch statement or a big if statement. I don't really like the switch statement. Kind of like that's what they do in Python, I guess. Python has no switch statement, right? No case statement. So it's all just use the if statement. If it's 1, well, whatever. If it's 23. Because I use 23 here, right? Do whatever. So you just handle the message here. So get message from message queue, and then flagging it. Okay. Handle message, and then you go sleep. Okay, so that's the general. Ooh. Okay, so that's the general idea on how will you do a background thread. Okay, so to emphasize, you communicate using messages, and the message has this message ID and some kind of payload. Okay, and you put in the message queue that's shared by the two threads, and here you decode. So this is the general structure for writing a background thread. So this takes care of the GUI to the background thread communication. This takes care of this part. So how do you do this part? right? This part, as I mentioned before, has to do with the GUI framework. The GUI framework has to provide some way for you to do it. In general, the GUI itself is something like this. The GUI itself is a big message processing loop, like I have it here. So you have to have some way to write a handler, a message handler, something like this, right? If message ID equals 0, do this. If message ID equals 23, do that. So this is a message handler here. And the GUI framework has to have a way of letting you putting a message handler into the GUI framework. So just go over roughly the general concept, what you do. Under Android, the main activity, this thing, main activity way up here, the main activity has a message loop inside, and you create a handler object to tap into the message loop. So handler is like a communication object, or you can think of it as a message handling function. So it's this stuff that I highlighted down here. You write this stuff. Message ID equals whatever, do something. You write some code like this. Now that would be a function, right? It's a function. But in Java, you can't pass functions around. C++ lets you pass function pointers. C# has delegates. Java, the only way you do in Java is you put your function inside an object and then you pass the object around. Okay, so that's what a handler is. It's an object that has a message handling function inside of it, and you create a handler object inside main activity, and you pass it in, and you'll be hooked up to the message loop for main activity. So that's a key concept. Okay, you write message loops. If you do it yourself, you have to write the message loop. If you do this part yourself, just like how I showed you have that message loop, right? Now to talk to the GUI, you utilize the message loop that's already inside of the GUI, and you tap into it by using the handler object. Now, a handler thread is a thread object that has a message loop. So, no space here. No space. So, don't need that anymore. So, the handler thread. So handler thread derived from thread. Handy class for starting a new thread that has a looper. The looper can be used to create handler classes. Okay, so the looper is a message loop object. A thread class, a normal thread class, does not have this infinity message loop inside of it that I just wrote. Okay, so a handler thread, handler thread derived from the thread class, and it adds this stuff that I just have, that I just wrote, a message loop. So when you use the handler thread, you only really writing this chunk in here. Okay, the handler thread is taking care of this stuff, or synchronize a message queue. It's taking care of decoding the message for you from the queue. It has something like this. Okay, it has a quit function. There's more to this. When we go over the actual quit function, there's a little bit more. Just this. Okay, so it has a quit function, it has a start function. Right, just like this, it's got that quit function. Start is something that it inherits from the thread. Oh, can't find start. Oh, see, okay, so it has a start function, and it's one of those things that I inherited from the thread. Collapse. Okay. So yeah, just think of it. It's a thread of a message loop. It's a thread that can contain a message handler because it has that loop. Because it has that message loop object, therefore it can accept this handler object. Okay. Just think about that's one of the reasons why do we have these threading classes, because of correctness and standardized terminology. So by providing us with a handler and a handler thread, the Google people are providing us with a standard class for implementing this stuff that I just implemented. In some languages, some libraries, they don't have this, and you actually write some kind of infinite loop that process messages. So I'm just saying that in this particular language, in this particular framework, they provided us with this stuff. So we have a standardized terminology. We have something that that's known to be correctly done. So we use this. So in the example, I'm not gonna code like this. I'll be using the handler and the handler thread. Okay, so that's the overview on what's this all about. What roughly what it is, what it really is under the hood. So I'll now recode the previous example where I add two numbers on the background using the handler thread. Okay, so it's the same stuff as before, two text boxes, add button, cancel button, a progress bar, and the main activity code is restored to the basic barebone code that I had before, references to these text boxes, progress bar, the output text view, an empty event handler for the add button, and then an empty event handler for cancel button here. That's all I have. Okay, so first handler thread. Okay, handler thread is the message handling thread. So before I do that, let me collapse this a little bit. Okay, so main activity. Okay, so the main activity is also a message loop, and it's gonna have a message handler. So I'll call it the GUI handler. Okay, and it's gonna extend the handler class. Okay, so organized import is gonna have this handler, os.handler, not the logging. So there's gonna be a warning. Never use locally. Okay, that's not the warning. There's gonna be another warning, but let's not worry about that yet. Okay, so it's gonna get chaotic. So I'm gonna mark the end of it. So this is the message handler for the GUI for main activity. Okay, there's gonna be a handler thread. So what should I call it? Service, I guess. Handler thread. Okay. So again, have to import that. Okay. So this is going to be my message handling thread. This thread with a message handling capability. Now this class is going to inherit this class, so it's going to inherit the message loop, but the message handler is separate, right? It's like here. So I know where I am in case it gets too chaotic. So service handler. Okay. So this is the class that is a thread, and it has a message loop inside, but the message loop is here. The message loop is the handler object. I mean, the message handler is in here. Okay, it's in the handler object. So this is the message handler for this. Note it's inner class, so you can access all the stuff. And similarly, this is the inner class for this, so that this handler, message handler, can access all this stuff here. Okay, so that's the basic setup before I even try this out. And let me just mark the end of this because there will be another class. Okay, let me just yeah, let me just stuff that in right now. There's one more class. Actually, at the end of the example, I have the summary table of what's going on. There's actually a total of 3 threads. The main activity is the GUI thread by itself. There's the service handler thread is a thread by itself that's handling the messages. And the addition, the adding is actually done on the 3rd thread. Okay. The adding has to be done on the 3rd thread so that it can be canceled. So, if the main activity sends an add message followed by a cancel message, right? The message handling logic has to spin off the addition into a 3rd thread so that you can see the cancel message and then cancel this thread. It's the only way for cancellation to work. If I try to add 2 numbers inside of this thread, and then I won't be able to process the cancel message. I'll be stuck processing the add. So hopefully it'll be more clear once I code the example. But there's another thread for adding the 2 numbers. Okay, and so I'll just stuff it in here. So this is like a top-down approach, I guess, to designing this thing. Okay, so I can now start coding some of this stuff. So on looper prepared, okay, handler thread on looper prepared. Oh, I have handler thread here already. Okay, so that should be a member. So callback method that can be explicitly written to execute some setup before the looper loops. The looper is the message loop. Okay, so actually here I should say this, huh? Okay, it's a member of a handler thread. So let me take also needs a constructor. Okay, let me take care of the constructor first. I don't need to give it a name. I'm hard coding the name here. So this is just to give the thread a name. Service thread, yeah. This is the thread name thing. This is this thing, the thread set name thing, because the handler thread, the handler thread is inherited from the thread, and the name helps you debug. This one needs a run function, so let me just get rid of the errors here. Okay, so it has that on looper prepare thing. On looper prepared. So this function executes when the message loop is ready. So what I do in here is I create a handler in here. Okay, so on looper prepared. Didn't write it, but okay. So I need to attach my handler here. The message handling thing runs on the thread where it's created. Okay, so if I create this object, if I create this object here, it's gonna be a member, right? Right, this is the message handler for this class. Okay, so I'm gonna create it here. Like that. Okay, so I'll talk about this next. Okay, the idea here is that once the message loop object is done, whatever, it's prepared, okay, I'm gonna create my message handler object. It's a timing thing. So so you create it here, okay? as opposed to just doing it here, for example. Okay, so let me talk about that warning they have here. This should be static or leak might occur. Okay, this handler class should be static or leak might occur. So I'm gonna copy that. It should also be down here, I think. Oh well. It's up here too. It's not used. Okay. So you can Google for that message. They'll try to explain it to you. I'll try to explain it to you too. And they have all kinds of solutions, quote, so-called solutions. Solutions are rather complicated. My solution is actually to suppress the warning. Here. Wait, here. Suppress the warning on the thread class. Okay, first of all, what are they saying? Okay, it could be memory leak. Okay, this thing is an inner class of this thing. Okay, and similarly, the handler is the inner class of the thread. So main activity has a message loop, and this is inside of it, and that's how it hook onto the message loop. And similarly here, this handler thread has a message loop, and so this handler is the inner class of that. So this class actually has a reference to this class, and that's what enables the inner class to access these elements, right? Like if you have a function here, you can access these elements like that. Get text, I guess. Get text, whatever. Okay. You can do this because you can do this because this class actually has a reference here, and this is something that Java does automatically. In some languages, like for example in C#, you cannot do this. You cannot do this, right? In order to access the parent class, what C# has to do is you have to pass in a reference. So let's call this C# is something like this, so that when you're constructing it, there, like this. Okay, so in C#, when you're constructing this object, you would pass in a reference to the parent class, and then you access it through the parent. Even if this is private, you should still be able to do that. Okay, even if these are all privates, you can still use reference to the parent to access it. Okay, because this is actually what's happening underneath the hood. It's just that this class has a reference to the parent class. Okay, but this being Java, you don't need this. You can access it directly, like so. Okay, but the idea is that first of all, the inner class has a reference to the parent class. That's first of all. The second thing is that this class can have this handler can have messages that are not processed. When people send messages, they can code it so that the message is sent sometime in the future, like 10 years in the future or whatever, right? So in that case, there will be a message in the message queue, and that message cannot be processed, or for whatever reason, some kind of programming logic failure, or whatever reason, there could be a message that's not processed. If there's a message that's not processed, then this class cannot be garbage collected because it still has a message. And then if this class cannot be garbage collected, this cannot be garbage collected because the inner class has a reference to the parent class, an invisible reference to the parent class. So that's what they're saying. There's a leak. That's what they're saying when they complain about the leak might occur. Because as long as it's non-static, this thing is gonna have a pointer to the container class, and this thing can prevent the container class from being garbage collected. So you can read their people's response to this thing, and they have some you know, like they try to solve that, but it's kind of messy. My solution is just, you know, the idea is that just process your messages as soon as you can. That's also why I have this structure here where it's like 3 threads. This thread is dedicated to processing the messages ASAP. That way there's no more messages in the queue. So that way the message, this class can always be garbage collected, and therefore the outer classes can also be garbage collected. Okay. So basically I just suppress this. So so you have to suppress it here, suppress it there. Well, this is the most local thing, I guess. Try that first. Right, if that doesn't work, suppress it outside again. Hey, I suppressed it. It still does that. I'll remove this. Oh, they didn't give it as an option. Oh, they did. Service handler thread. Oh no. No, I want to suppress it here actually on the class. Here, suppress this. There. Right, suppress the handler leak for this object. And similarly, they're going to complain about this too eventually. You know, this is also a handler leak. It's also going to have the same problems. It's also going to have the same warning that if, you know, messages are stuck in here, you know, then this parent cannot be garbage collected, basically. Okay. So back here, so I did this. You just create the handler here, but you get that, you know, memory leak warning. Main activity on create, yeah. Okay, so main activity, well, it has to have a service handler first, right? I defined a class, but I didn't define the reference. Nice, service handler thread. So on create, well, first you have to allocate the object. So you have to start, and then you have to call get looper. So this is like a thread, right? So start basically starts the thread, starts the message loop handling as a separate thread. Okay, starts this thread, the second column in this middle column here. It starts this thread. Okay, and next is that get looper thing. Get looper returns a looper, but I'm not actually getting the looper object. Okay, so did you talk about this or? So the key is I'm not actually getting looper object, right? There's nothing here on the left side. It's not like, you know, some object. Ooh. It's not like there's something here, right? I'm not actually getting looper object. The purpose of this line is to block until the looper is ready. Okay, so this function get looper. If this thread has been started, this method will block until the looper has been initialized. So it's a way to control the timing. So don't go on. Stop right here. Don't just wait. Don't execute. Wait until this looper object is done. Okay, when the looper object is done, because of this thing here on looper prepared, when the looper object is done, the message handler will also be done. Okay, so the next thing I have here is on destroy, and you quit that thread. Okay, so sort of makes sense, right? You know, on create, under on create, I'm starting the thread to handle the messages. So, I should do this too. Okay, so in on destroy, I'm gonna quit that thread. quit. Okay, now there's actually two quit functions. This is not safe, and this is the safe one. But the safe function requires API level 18, which is pretty high. That's Android 4.3. So I'm going to use quit. Do you talk about quit and quit safely? So I talk about quit. Basically, previously I had that little, yeah. When I talk about like the concepts, I coded that message loop where I just call thread.interrupt. Well, you also have to clean up the message queue, and so that's what's not safe about it. It has to do with the message queue cleanup. Quit safely. Look at this. Okay. Causes the handler threads looper to terminate as soon as all remaining messages in the message queue that are already due to be delivered have been handled. Okay, so messages in the message queue have been handled. It's gonna wait for that. Okay, and also pending delay messages. Remember, later on it will become more clear. When you send a message, you can schedule the message to be sent sometime in the future, like 10 years in the future, like I said. You don't have to send a message immediately. Pending messages with due times in the future will not be delivered. So these two things makes it safe. Okay, they're gonna wait for the messages to get handled, and they also get rid of the pending messages. Okay, whereas quit doesn't do that, and quit causes the looper to terminate without processing any more messages. Okay, that's why using this method may be unsafe, because some messages may not be delivered before the looper terminates. So basically, this is safer because of the way it cleans up the message queue. Okay, so that's why it is. But it's API level 18. It's like, who has that, right? I mean, so I'm on Android 4.0. So so I don't have that. So I'll be using quit. But in the future, use quit safely. Okay, so that's all there is to the destroy function. So just kind of go over what I'm trying to do, right? Main activity is going to create a message, add two numbers, and in the service handler, I'm going to see that message. Oh, the message says add two numbers, and I'll create a new thread to add the two numbers. And in this thread, I'll send a message back here saying I'm done adding two numbers. Okay, so I'll code it basically using this flow from start to finish. Okay. First thing is add two numbers. Okay. So here, the add button handler, service handler thread, add two numbers. Well, it's not there yet. I call it GUI add two numbers to show that this function will be running under the GUI thread. So num2. Not there yet. I have to put this over there, right? Add two numbers. Okay, void public. Okay, so as I mentioned, it's got this GUI prefix because it's currently inside the GUI thread. The GUI thread. Okay. So the GUI calls, this. Okay, so I'm gonna send a message, okay, to the service. To the service handler thread. So the way you send a message is by using the handler. Service handler. There's a function called obtain message. This thing, obtain message, returns a message. It's like a factory function. Okay. Oh, there's versions of that. So the message object. Okay, before I actually write this in, I'll go over the message object. Don't need this. Okay, message object. The message object has what? Okay, this is the message ID. In my conceptual example, I had message ID in the payload. Okay, the what is the message ID because it's type int. And this one, the obj, that's the payload of the message. Okay, so obtain message, different functions here. Oh, they also have arg1, arg2. Okay, lower cost alternative. Whatever. I'll just use the obj, the payload. Might be more efficient to use those two. You don't have to unpack the array. Okay, what's it? Obtain message. Okay. So I'll be using this one, but it's certainly in this case I'm adding two numbers. I could be using these two, but as an example, I want to be as general as possible. This is more general. Okay, what? This is your message ID. I'll fill in something later on. Okay. And the object, I'm adding two numbers, so I'll be throwing in this integer array here, num1, num2. So message ID, let's see. This is service handler, so I should put something in here in the service handler, right? Where is it? Oh, it's right in front of me. Okay. Static. What's that? Add two numbers. Okay, about the IDs, about these IDs, they can be anything you want. So I'm here. I'm in the developer reference message class. This what a message ID field. Okay, each handler has its own namespace for message codes, so you do not need to worry about yours conflicting with other handlers. So you can use any number here. You don't have to make it above 1024 or something, right? So just assign whatever number you want. Don't worry. It won't collide with other message IDs. Okay. So it's gonna be this, right? So add two numbers like this. Okay, so obtain message returns a message object. Well, okay, let me code it like this first. G, right? So that's a factory function to create a message object, and then you want to call send. Okay. Send to target. This one sends out the message. Right. Create the message, send the message. Now usually, this is the way they code it. Usually, is to get rid of this, they just chain it like this, right? So create the message, send to target. Like this. Okay, like that. And that's how I'll be coding it too in this example. Send to target. Okay. Warning. Should be accessed in a static way. Oh. Okay. Whoops. Should be yes. Oh. Hey. Capital. Okay. Oh, capital. Okay, got rid of that static field warning thing. So I'm at this stage. Okay, so This is the listener event handler for the add button. This is, you know, add two numbers. This is sending, generating a message and sending it. So I'm here now. Next thing I have to do is actually handle the message here. Okay, so I did this. Next thing I handle the message. Extend the handle and right handle message. Well, I'm surprised that's not required. Handler. So it's this handle messages. Well, it's a lot to this handler. It's handle message. That's where the message handling logic is. So this one. Subclasses must implement this to handle messages. I think maybe they should have made it abstract or something. Yeah. Oh, they didn't make it abstract. See, if they make it abstract, I just put my mouse over this thing and, you know, this box comes up and I don't have to type it in. Okay, handle messages. Have to do this. I don't think the base does anything here. Okay, so like I said before, it's that big if loop, right? Or case statement, switch statement if you prefer that. So what? That's message ID equals. There we go. So add two numbers. Like I mentioned, you need to create a new thread to do that. Oops, that's the wrong slide. Okay, you need to create a new thread to do that. The reason is that you know if the GUI thread, if they send like an add message, the add to number message, and then send a cancel message. Yeah, so if I do it in this thread, if I spend like 5 seconds adding here, I'm gonna miss out the cancel message. By the time I see the cancel message, the addition is already done, and there's no way to cancel it. It's meaningless to cancel it. So this loop, this message loop thread has to handle messages very quickly, so they can handle cancellation events. So I'll create a new thread to do that. Okay. So, instead of adding it right in here, I'll create a new thread to add. So before I do that, I have to decode this message. Right, remember there's this arg1, arg2 thing. That would be better for this example, but I used the OBJ. I packed up the numbers like so. Okay, so it's gonna be like integer it's gonna be like that. And I'll write a helper for myself to keep this from getting too big. Okay, so not private. Okay, so same thing here. So the GUI add to number is the running on GUI thread. Oops. Yeah, currently inside the handler. No. Inside this one. Thread. Okay. Okay. Anyways. When I'm handling the message, I kind of decompose, kind of cast this back into the true form. Something like that. Okay, so this is going to go over here. This is where I'm going to create a new thread to add the two numbers. So thread, I need a thread object, right? Let's call it adder thread. Okay, and I need to code this in. Do I need this first? Yeah, let me code this in first. Let me code in the runnable first. It's gonna have the two numbers I'm adding. The constructor needs to provide those two numbers. So constructor provide two numbers. Okay, and here comes the run function. It's basically a big wait statement, right? Let's say 6 seconds. Thread.sleep 100 milliseconds. Now I need to update the progress here, right? I need to update that progress bar here, but I'm gonna leave that out for now. I'll add it back in a little bit. So there's, if they try to cancel the thread, it's gonna be that interrupt exception thing. Right. Do nothing, exit. So it's just, that's the quit logic. See. So after that, that wait statement here, it's num1 plus num2, and I have to put this back. I have to send back a message, but I'm getting ahead of myself. Okay, so previous I'm here. So I just coded the runnable so I can actually create it. Okay. So in the very beginning, this is going to be null. I mean, keep in mind this could be visited multiple times. This is the message handler function, right? It's all I'm saying. All this guy knows is that it has a message. The message is to add two numbers. Okay. So on the very first time, this is going to be a null. So you need to kill the, if it's already running. Okay, exit if it's already running. Okay, that's the idea. I'm trying to do that here. If it's alive, kill it. Okay, so I kill the thread if it's already running. Okay, so interrupted exception. Gotta handle that. Do nothing. Okay. So I create a thread by using a runnable, right? So adder. So what would I say? Runnable. So num1, num2 is from these num1, num2. the two numbers I'm adding, and then new thread, use this runnable. So, and then start the thread. Okay. Okay, so I handled the message. I saw the message IDs, add two numbers. So divert to this function, add two numbers, create a new thread, add a thread, new thread. So that's why I just did new thread. New thread requires a new runnable. It also requires killing off the previous thread if it's still floating around, so to speak. So now I'm over here. After I create a new thread, I'll be in the run function over here. The add a runnable run function. So I'll be here. I need to update the progress bar. Okay, that's actually not in this. Yeah, I need to send whatever updates. So there are two things I need to update, right? I need to update the sum, or I also need to update the progress as it happens. So same thing as before, but I need to be coding the handler. Oh, let me just bring this in. You can see what I'm doing here. Use this thing to navigate. There's just too much stuff for me to scroll around. It's this thing, the GUI handler. So same thing, the message ID and the payload. So I'll define the ID here. So what the two things I want to do is update progress bar first of all. Update progress bar. I'll give that a message ID of 0. And the update the output text view, right? This output text view is that there's just a label here, this label here, the output text view here. Okay. So those are my two message IDs. I need to put them here before I actually create the message. Okay. So I go back to my service handler. Go back to here. Wait, no. The runnable. I need to go back to my runnable. Go back to the run here. Okay. So update progress bar. I need a GUI handler. Don't have it apparently. Okay, so I have to create that GUI handler. See, I just defined it, but I haven't actually created it. I don't think I have created it. That's it. So now remember, the handler runs on the thread where it's created. Okay, so that's why the GUI handler has to be created on the main activity thread. The GUI handler is the message handler for main activity. Okay, so I'm gonna create it on this thread here. Okay. And actually what's happening is that the adder runnable needs access to the GUI handler so they can send a message to the GUI handler. Okay. So I created a GUI handler over here. I need to pass the reference in all the way over here. So where was that constructor thing? Pass in through the constructor, right? Okay. F3. So not simply this. Now I have to like that, right? pass it in here. Okay. So pass it in. So handler, pass it in. Okay. Okay, like I was saying before, I'm in the runnable, the run function. Here I'm making progress. Need to, use the GUI handler now. I just added, the GUI handler. Obtain message. Oh, but we all know what it is. Right, the first argument is the what. Okay, the what. Handler. I just added that update progress bar. And next one, the progress bar takes an integer, right? I'll do that. Send. Oh well, this needs to be taken care of first. What was the I? Well, it's I definitely. That it's a little complicated. Let me just do it out here. Yeah, you need to be rounding it. So it's definitely I divided by, it goes up to 59, right? It goes from 0 to 59, so it'll be 59. F, make it floating point to avoid it, so it won't be integer division, times 100, and round it off. Yeah, round that off. Yeah, so this is a fraction between 0 and 1. This will be the percentage multiplied by 100 to create a percentage value, and round it off to an integer value. Okay, so I'm just gonna put it all in here, but it's too confusing. Now I can call send, right? Send to target. Okay. I hope that's it. And I need another one down here to send the sum. This one's easier. This one's a sum. And then the message ID is the sum, right? The update output TV, output television, output text view. Okay. Yeah, it's okay. Send a target. So I just wrote this part. Where inside the run function, I'm adding stuff up. I'm sending the progress. I'm also sending sending the sum when that's done. So if this is done, like over here, the GUI handler here needs to handle that message. So GUI handler, where are you? Where's the GUI handler? Good thing this outline view is the key. Okay. This doesn't do anything. Base doesn't do anything. How could they do anything, right? Like, they don't know anything. If it's equal to this one, remember this is on main activity thread. Okay, that's why this thing can, update it directly. I just put the integer inside of that. OBJ, right? OBJ. Let me see. Need to cast that. Okay. Dot set progress. Okay. Handle the other message ID. Wait, did I? Oh, I put it in here. yeah. I should use that. Oh, why am I scrolling? I should be using this, right? What is that? Runnable. Run. Okay. Yeah, I should make this into a string. Okay, so that should make it a string. Go back to my handler. GUI handler handle message. Okay. Because previously it was a number. Obj. Now it's a string. So what was it? Output TV, right? Set text. Okay. So I've gone through the whole thing. Set progress bar, set text. So handle message, depending on the message ID, set progress or set text. Okay, update the GUI. There's no cancellation yet. I have to add that in. Okay, it's not fully done yet. So let me just run this. Actually, there's some errors I have to fix first. Go here. What? What's that? So is it the text box? This text box, right? Okay. Oh. Okay. Was not on screen. Okay. So I'll do it again. 2 plus 8. The rotation broke the thread. Okay, 2 plus 8. So 10. Okay. So this code works, but cancel doesn't work yet. Well, cancel is not there yet. So now I have to add in cancel. So to add cancel is the same idea as this flow. I need to do this message thing. So I'm starting way back here again. I'll just kind of progress this way. Okay, so obtain message, send to target. I have to message, but before I can even do that, I need that message ID, right? Handler has a handle. Service handle. Oh, there we go. There we go. So I need to add a new message ID, static int. Should I call it cancel or something? Cancel. Okay, I guess. Okay, cancel. So new message ID here. Now go back to the. Okay, the cancel event is going to trigger. What I had before. I had GUI add to GUI cancel, I guess. Right? This is not there yet. I have to add this. HandlerThread triggers this. Where should I put it? I'll use this list again. So I had this, right? No. I had this. Okay, so I had GUI add 2 here. So right below that. GUI cancel, and this thing just creates that message. There's no payload. It's a cancel message. The message ID is cancel, so cancellation. Oh, why is this bad? Obtain message ID equals cancel, no need for payload, send to target. So I'm over here sending the cancel message. Over here handle message. I have to handle the cancel message. Where is it? Handler here, handle message over here. Okay, so here I handle the cancel message. Now in general, you want to divert to some function, because you could have a whole bunch of stuff here, right? You could have like 20 different messages or something here. So right, so once again, I'm gonna divert this to an external function. Like I said, in this example, I could stuff it all in here, but in general, the structure is that you could have a lot of messages, so the handling is diverted outside. So yeah, here I have to add 2 numbers. So I'm gonna do the cancel here. Add a thread if it's not null. Okay, if add a thread if it's still alive. Okay. Kill the adder thread. I do that by using interrupt. Join. Okay, join. Now I have to do this whole thing in try block to because join is gonna throw the interrupt exception again. Okay. Don't do anything. Okay, obtain message. Yeah, so obtain message, because I'm here. I'm over here. I was in the actually I'm over here. Okay, so I was in the handle message. I have an if statement to trap the message ID. If the message ID is cancel, I try to cancel it right here. So what I need to do now is update, report back to the main activity. The operation, the addition operation got canceled. So I already have that, right? I already have that thing up here. So it's send a message to main activity saying that this operation is canceled. So this form. Hate it when you press enter. 3rd time enter. Gosh. Okay, GUI handler. Yeah, I want to say operation canceled. Attach it to that. To the message. So I'm sending a message to update the text view saying the operation canceled. Okay. Oh, wait, I also need to send it. Yeah, obtain message just, creates the message object. Okay. So create a message ID being update the output, updated with this string operation canceled. So this should be done, right? Yeah. So, because this part's already there, it was coded before. Okay, so I just coded this part here. So let me run it and try to cancel the addition. So 5 plus 9 add. I'll let this add go through first. So I have something down in at the text view here. So 14. I'm gonna make it like 3. Add. Okay, I'm gonna cancel. So operation canceled. Now, just to make it a little bit more, this example is basically done, but just a couple loose ends. Like what if I add? What if I hit add 2 times? I need to cancel the previous add, right? Right. Well, that's one way. Maybe the other options to queue it, to do both adds, but I'm gonna cancel the previous add. And also the other thing is the on destroy thing, because that thing's not canceling. Like what if it's adding right now, right? So currently I had this. But what I really want to have, now that I have the cancel thing, right? Is really I want to add is this. So cancel it. Can't cancel the addition and then do the quit. That's one loose end. The other loose end is what if I add? What if I hit the add button 2 times? See, when I hit the add button, it's gonna go to here, GUI add 2 numbers here. So that's gonna go to the message handling function here. Okay, and the message handling function is gonna go over here, add 2 numbers. Oh, okay. Oh, apparently okay, if the previous thread is alive, I canceled it here. Okay, that's okay then. I'll try that. Just make sure adding 2 numbers. Okay, wait. Run again. Two plus 3. I'll add this one through. Okay, now 2 plus 5, add. Before it finishes, I'll click 2 plus 9, add. So I cancel the previous one. So 2 plus 9, 11, okay. Okay, so clicking add 2 times will cancel the previous add. Okay, so that's it for this part of the example so far. There's one more thing, the runnable thing. So that currently this whole thing's done by message passing. There's another mechanism to instead of message passing, the post. So that's the topic of next segment. Okay, so to wrap up the coverage of the handler thread, the handler object. So one way to communicate between 2 threads is to use to generate a message and then to pass it through. And there's another we call post. So if you look at the message handling, there's a lot of just formalities. Especially in the path from here to here. Okay, from adder runnable back to the main activity. This can be simplified actually. Okay, so let's go over what happens. Adder runnable. Oh, adder runnable here. So what they're doing, what's currently being done is I have to create a message, right? With these arguments. Call send message, and then And then in the handling message, I break it back down. I extract these arguments. I extract progress. I extract the message, whatever. That I do this. So it's kind of like formality, because like this message ID, it can start at 0. The message ID can be auto assigned. I have this blob here coding it 0 and 1, but because like the website says each message can have their own like this, each handler has its own namespace for message codes. So this message ID it can always start 1. So the message ID part is just a formality. The framework can actually take care of that. And also this part where I bundle the things onto OBJ and then like split this back up again into whatever, that can also be done by the framework. That's just another formality. And this part, matching it to message ID, that's also another formality. So the true mechanism underneath the hood is this function, but there's another way to do it. Just to have the framework, to have the class automatically create a message ID, automatically, find the right message automatically. Do this. So the way the alternative here is that there's a post function that can do a runnable. It's kind of like let me try to make a pseudocode for this idea. So I sort of got rid of the message loop, right? So the idea is that all those formalities, I can just create an array of runnable objects, and then I can just run them according to the message ID like this. Okay. So the message ID is used to look up a runnable object inside an array. So this is kind of simpler. So I just specify a runnable array of runnable objects, and just run the right runnable depending on ID. So, and that's the idea behind the post function. Post, just run a runnable. Okay, where's the post? Post runnable. Post runnable causes the runnable R to be added to message queue. The runnable will be on the thread to which this handler is attached. Okay, the runnable will be executed. Okay. So it's something like that. So I'm gonna update. So this can be simplified. The GUI handler can be simplified by using runnable, by using this post function. The post function gets rid of this handle message function, because it's essentially something like this. They will automatically know which runnable to run. Okay. So So basically this class is totally empty now. Yeah, so I was thinking, why didn't they make the handle message thing, why didn't they make that a requirement? Why didn't they make it abstract? Like this. Yeah, this is not required because they have this alternative mechanism to basically automate this whole function. Just automate this whole thing here. That's why this thing is actually not required. So right now GUI handler is totally empty. Okay. But you still need it. I'm using the runnable feature, the post feature. Okay, so I need some runnables. Yeah, the runnable should be an inner class of main activity, so that the runnable has access to these variables here. Try to collapse everybody. Scroll bottom. Okay. So it should be here, right? Okay. Let me call it GUI update runnable. So I'm gonna have one runnable for both, for the whole GUI basically. Actually, this could be int. Okay, I need a constructor that sets those two. Okay, and progress this dot. Okay. Oh, run function. I'll come back and write this a little bit. So to use the post function instead of this, okay, instead of this obtain message thing, post new what GUI update runnable. Oh, I guess it has to be null then. Oops. Okay, so not every time I want to update the progress bar, right? If I only want to update this, then the progress parameter needs to be null or something. Okay. Okay. Okay, that's why. Yeah. Okay, so this should be something that's nullable. Where was I? Okay, so I'm in here, I'm in the cancel. So don't update the progress bar, just update the text saying, you know, operation canceled, right? Okay. So what it's saying is that run this function. Run this function on this thread, on this GUI handler. Okay, and the GUI handler is residing on the main activity thread, on the GUI thread. Okay, and basically, I guess underneath they construct messages or something. Well, yeah. So no need to write messages. So here, same thing. Oh, I should copy and paste. So here I'm updating the progress. So the first number is the, you know, the progress number. The second number is the text. So here I'm updating the progress. No change to the text view. Okay. Copy here. And this is the other update. So here I'm updating, you know, the progress is already hit the maximum here. Progress updating is completely here. So here I'm not updating the progress bar, I'm only updating the text view. Okay, so I need to write code here to actually update progress bar and text view, right? So if remember, either one could be null. So if it's null, that means if this equal null, progress. Okay, set progress, right? Okay. Where's text? Yeah, text. Okay. So if they use null, this won't run. Don't update the progress bar. If they use text equals null, don't update the text view. Okay. So I think that should be okay. So I'm gonna run it. So it's the same thing as before, just it just has a new function for updating stuff. Yeah, so it seems to be working. So see if the text. Okay, so that's how it is. Okay, so that's a demonstration of the post function, and that completes my coverage of the handler and the handler thread class.